Yes, it is a type of energy, but it's not the answer here. Can I go through? Okay, by the way, so what we're doing, right, is I'm giving everybody 1.5 minutes per mark to do the questions, then I go through. And we're going to go through the whole entire worksheet properly. Okay? Now, for this one, water is transported to the village, pulled by a tractor, blah blah blah. Combined mass is 4,100 when it's empty, 6,500 when it's full of water. From this statement alone, we should be able to derive a conclusion that your mass of water will be whatever when you're full minus the empty tanks. Agree or not? Okay, 6,500, 4,100, the difference is 2,400 kilograms. That's one. Now, at the start of the journey, you accelerate from rest along a straight horizontal road. As your speed increases, one form of energy is decreasing. In other words, your kinetic energy, okay, because as you accelerate, your velocity is increasing. Agree or not? If your velocity is increasing, that means your KE is increasing. But energy cannot be created, it has to come from somewhere. So where is it coming from? Okay, as we know, anything that involves movement must first have chemical potential. From your fuel, from your petrol, in this case it's a tractor, so probably diesel. Okay, so the type of energy that's decreasing is your chemical potential energy. When we were going through this topic, I did mention that we are not tested on chemical potential energy, but we must know of its existence. There are ways to calculate this, but we are not going to do that in O-level syllabus. Okay? But we need to know what it is. It's the energy that's present in your fuel or your food. For humans, of course. Cool? What happens to this energy? As I mentioned, okay, you need to obtain this. So, your chemical potential energy is converted to kinetic energy and what? Not work done. Heat or thermal energy. Why? Because friction, air resistance, friction at the road, all this kind of thing, you will lose energy. In fact, apart from just heat, you also have sound. So the chemical potential energy is like the crucible from which all the different kinds of energy will stand. Get what I'm trying to say? Okay? Now, the village is located on a mountain, vertical height 350 meters, this is your H. The moment I tell you this, and the moment I tell you this, you should know what kind of energy I'm going to ask actually. Wow. You guys are very hungry.
Yeah.
Okay, so calculate GPE. GP formula is mass times G times H. Your mass of water, as we established just now, 2,400 times 10 times 350, and your answer will be 2041235. Yes. Okay, so from here then, if you leave your answer as this, that's perfectly fine. Okay? If you want to use 2.04 times 10 power 7, you want to use 20.4 megajoules, whatever other iteration using your prefixes or standard form, it's perfectly fine.
And then the part you need to write like the velocity.
No. I'm just talking about the energy. What happens to K? What happens to chemical potential energy? The variations in KE is not part of the question.
Oh, so it's like two marks.
Yeah? This energy is what? Is your chemical potential. Okay? Ethan, okay? Cheryl, good? All good, Alright. Question 2. 1, 2, 3, 4, 5. Again, 7.5 minutes ish. Let's go. There might not be wind. Yes. Okay, come. Let's go through. State is the principle of conservation of energy. Cheryl? Or not Cheryl? Ethan?
It states that energy cannot be created or destroyed. Energy can be transferred from one source to another.
Very good. Okay, energy cannot be created or destroyed. Only converted from one store or one form to another. Okay, the actual definition has 3 parts. This one has 2. One mark here and one point here and 1 point here. Okay, the last statement actually should say total energy within an isolated system remains constant. Remember? Okay, but it's a 1 mark question. Don't waste your effort. Okay, so rule of thumb, guys. 1 mark, we write this. 2 marks, we include the last part. Okay? Then overall. Okay, so the last part that we normally include for this statement is total energy in an isolated system remains constant. Okay, this one is only if 2 marks. Yes.
Last time I only converted.
Cannot be created or destroyed, only converted. No. Now, your total kinetic energy in a second, 111,240, efficiency is 77%. The total energy by your tidal currents, guys, this fella, when they say total energy, and the currents is the source of your energy, because your currents hit the fucking waves and it can turn, right? Okay? So this guy is your input. You want output. Okay, the definition of efficiency, this thing, okay, efficiency normally we will use N, okay? Small n equals to output over input times 100%. This is the formula. Okay, so if I have 77% efficiency, so 77, your output is what you want to find out. Input is 111240 joules every second times 100. Naomi, what's your output? Eight five six 54.8 joules per second. But this is not what the question is asking for. The question is asking energy output in 10 minutes. So, total in 10 minutes. Okay, you need to include your total duration. So, you have 85654.8 times 10 minutes times 60 seconds per minute. So you this one times 600, works out. 5139280. Rounding up, we just use that formula. 1, 2, 3, 4, 5, 6, 7. Questions? This was math. Cool. Give a reason why the efficiency of a tidal generator is not 100%. John?
Some kinetic energy converted to heat energy sound. That's why not 100%.
Okay. So some of the energy would have been converted Both wind turbines and tidal turbines are potentially eco-friendly and inexpensive. What's an advantage of using tidal compared to wind? So, we established one just now. We will say that tides are always present. Or you can say they are very reliable. But wind is not so reliable. What's another possible benefit? Common sense. Think about it. Anyone? Why? How come Singapore cannot use wind turbine? Yeah. Wind turbines occupy much more land space. And also because Singapore is a metropolis and it's covered by buildings, so you cannot get enough wind anyway. But this is our main goal. Okay. Okay, so do take note of this, guys. Alright. The questions are not very difficult, as you can see. It's just a little bit of interest. Okay, so that when I start on the mock papers, it becomes easier. Okay. Now, let's see. 1, 2, 2. Okay. Oh. 1, 2, 3, 4. What the hell? Okay, 5 minutes. Sorry, 6 minutes. For question 3. Okay. So figure 3.1 shows phone drop at certain height free from rest, blah blah blah. You are supposed to plot gravitational potential energy versus kinetic energy. Okay. Should clearly show the relationship between them. This relationship is an inverse relationship. In other words, when one goes down, the other must go up. Right? Okay, so how I'm going to draw it is, okay, let's say this is our max now, okay? Wherever the max is, I don't know, some random arbitrary maximum value. You will start with maximum GPE. Agreed? Because you're like drop from rest, huh? Okay, so your GPE is over here, it starts here. But when you drop, it is not going to be a straight line. Okay, and I'm going to tell you guys why. So let's just draw it first, stay follow. Don't worry, I'll explain everything. Okay, it's a bit of a curve. And let me tell you guys why. Okay, so yes.
Okay, I thought before hit the ground shouldn't hit the maximum.
Before it hits the ground, what?
Before it hits the ground, it shouldn't be at maximum.
Right before it hits the ground, it will be at maximum, then it hits and goes to 0. So the next instance after this, right, it will instantly drop down already to 0. Because you hit the ground, it's not moving.
Huh?
Your kb is a function of velocity, right?
Yeah.
So your velocity, you go right before you hit the ground, you are at your maximum, then you hit, and then you are at 0.
Oh.
Because once you hit the ground, you cannot be moving anymore, you are bouncing back up. Correct? Okay, but that's not what I'm saying. So, why is it a curve? Okay, everyone here, I'm not sure where else who is at, but definitely you all have done forces. You all have done kinematics, correct? As you are falling, what is acting on you? Yeah, air resistance, but gravitational acceleration is what I'm going for. Correct or not? We have gravitational acceleration. When we have gravitational acceleration, means we are accelerating downwards, which means our velocity should be increasing. Right? Okay? But velocity increasing, this can be a linear value. a linear graph. Why is it a linear graph? Because gravitational acceleration is 10, it's not going to become 10, then 11, then 12. It's not changing that much. But this is not a function. What we are drawing is not velocity. We are drawing KE. KE is half mv squared. It's a quadratic curve. Are we in agreement? As I speed up, my velocity increases linearly. No problem. Because it's accelerating due to gravity, which is constant. But half mv squared is a quadratic change. So it will curve upwards. And then of course your PE will slope downwards as well, because they are inversely related. Questions? John? I give you some time to absorb this first. Okay, it's not a straight line, it's not so easy like this. Okay, it's a curve down, curve up. You got your what? Okay, but you got K correct? Okay, K correct about P right? Oh, but you are accelerating downwards, huh? Gravity is continuously making you go faster downwards. So your PE should drop faster and faster and faster. Okay? Now, part B, game figure 3.3 shows a person hitting a billiard ball, blah blah blah. Move and hit another ball, while the other fellow moves forward at constant velocity. Mass of ball X larger than ball Y. See, the velocity will be greater than, equal, or less than your initial velocity. Pahan, what do you think? Greater. Okay. Why is the velocity of Y greater? Okay, so there's like intrinsic understanding, right? That your energy conversion, because in this case everybody's on the same table, there's no change in GPE, there's no heat, there's no whatever, right? So it's just KE converted to KE, which means it's half mv squared converted to half mv squared. But your masses are not the same. Your second guy has a smaller mass. So if this fellow goes down, that means of course that this guy must go up. Correct? Because your KE at the start is constant. Whatever energy that you have at the very beginning is a constant value. Which means if I'm using a smaller mass, that smaller mass will fly forward very fast. It's like I throw a bowling ball at a tennis ball. Then, like let's assume that immediately after impact the bowling ball stops moving. So all of this KE goes to the tennis ball. So it's such a smaller mass, it will fly forward very fast now. Make sense? Alright, good. Okay, so yes, indeed, K velocity of Y will be greater than V. Okay, and the reason for this is because since mass of Y is smaller than mass of X, but all kinetic energy was converted or was transferred, okay, then of course your velocity of Y is bigger.
Since for our Y is smaller.
Mass.
Oh.
Is this not mass?
Use the mom.
Man is
Use the mom.
mom. Why would I join like
Your mass.
ASS, bro?
Oh.
It's painfully obvious. Right, Cheryl? She nodded. Okay, so copy down the answer and get to question 4. Question 4 is quite challenging, okay, I must say. It's on pressure. Anyone have pressure? Okay, 1 mark, 2 mark, 3 mark, 4, 5, 6, 7, 8 marks. I'll give you guys about, give you all a little bit more time, 15 minutes. Okay, read through the questions. Oh, sorry. Read through the question. Make sure you understand it. It's on Bernoulli's principle. Yeah, I'm going to go. I'm coming to you back. Okay, let me go through this question properly because I think this is a concept that's a little bit hard to understand. Ethan, you want that? Okay, so in an experiment to investigate Bernoulli's principle, okay, the effects of air velocity and pressure is recorded. So, Bernoulli's principle explains why there is a pressure difference, okay, which generates lift, okay, which is your upward force that acts on the wings of the aircraft. So, okay, let's take a look over here. Okay, let me explain this, alright? If air moves faster on top than below, then there will be a build-up of air pressure below. Because below is simply traveling slower than the top. Okay, so yeah, so as I was explaining, it's like imagine two queues of people. Okay, one side moving a lot faster. Down here there will be a build-up of people, correct? Okay, and that build-up causes a lot of air pressure. So this air pressure, okay, build-up of air pressure. Okay, but what is pressure? Pressure numerically is equivalent to force per unit area, which means I will have force generated below the wings. Do you do it? Following so far? Okay, and pressure, as we know, acts in all directions. Pressure is acting this way, this way, this way, this way, and then you have your upward force. All of this is your lift. Follow it. Yeah?
So there's a air below the wing.
Yes.
Lower than the air before.
Correct.
Why?
Because below the wings, okay,
Oh, right.
there's more resistance, right? On top you have so much space all the way up until the atmosphere where your air can move. But below you only have the wing and the ground. There's only that small gap. Okay? Okay, so with that being said, with this build-up of air pressure, then you will have a lot of pressure below, but not so much pressure on top. Maybe you have a couple of arrows. Because your pressure on top is lower. Because your air is moving faster. There's less people caught on top of you. Okay? You know me? Okay, So, when this happens, if pressure on top is lower, that also means that your force that's acting downwards is lower, is less than your force acting upwards. There's less green than red. Okay? So it is this difference in pressure that generates a difference in force. And if when your upward force becomes big enough, your plane will lift off. Okay? Okay, So let me just go through the question. Okay? First part is just data. Alright, just get your data. State the relationship between the speed of the aircraft and the air pressure difference. You need to calculate this first. Okay? You don't have to use like your calculator and accurately press. Just take a brief look. 500, 700 is for 200 plus. Alright? 794, 551. Now it's 980, closer to 500. Not exactly 500, it's got closer, right? And then 1531, 2205 is about 700. This is close to 1000, this is more than 1000, this is almost 2000. So the trend is very obvious, right? So you just say, as speed increases, okay, your air pressure difference will also increase. It's just data abstraction. Are you okay so far? Then this part actually backs up, like tells us why exactly the plane always needs to be traveling so fast until it lifts off. Why is acceleration so powerful? It's because I need to obtain a high enough speed so that I have a high enough pressure difference, which leads to a high force difference. And this force difference allows the plane to lift up. Is it becoming clearer? Still no? Why? Okay, where are you lost it?
The whole thing.
The whole thing? Okay. It's okay? No? Did you know that below travels slower?
Yeah.
Okay, if below your air travels slower, then there's a build up here, correct or not?
Oh,
The rest of you continue first, huh? Continue the next question first.
oh, let me do that.
You can picture, of course all the air is going to the same place, right? So you have two queues of people, both merging into one lane. One side going faster than the other. Now here will clog up, right? Because they're traveling slower. Right? Okay, so now if this side clogs up, if the bottom side clogs up, the air pressure here, a lot of air will be caught over here. True? Caught. C-A-U-G-T, right? When your air is caught over here, it generates air pressure, a higher air pressure than on top. Now here going very freely, now here very slow. Agreed? So this air pressure, which is force over area by the way, generates an upward force, the red color arrows. Correct? Now here also got air pressure, of course. But there's lower air pressure, which means there is lower force. So if there's lower force here, higher force here, at some point this upwards becomes so big, the difference between them becomes so big that I'm able to lift the plane up.
Oh.
Okay? So in your own words, try to phrase the answer for part B. Okay, Bernoulli's principle is essential to produce lift force. How is the lift force produced and how does this cause the aircraft to take off? Okay, just in your own words. If you want to use point form, go ahead. I'm going to go through it real soon. Okay, I just want to see whether you guys can at least get the concept, even if you do not phrase it. Okay, don't worry about exam criteria or keywords or whatever shit. You are at D?
Yeah.
Wow, okay. Think about how fast you have to go such that your upward is enough to lift up the plane.
I don't know how much pressure you know.
You need to know what the pressure difference is like.
Oh. Maybe the form wing of the aircraft.
Correct. But the weight of the aircraft gives you a benchmark. To fly, you need to overcome your weight. Yeah. So try to think about it.
How much air pressure?
How much what?
Air pressure.
How much air pressure?
Yeah.
What do you mean how much air pressure?
How different is speed?
When you go faster, the difference in air pressure increases, right? And with the difference in air pressure, you will have a difference in force generated, right? As you go faster, your upward force, the difference between upward force and downward force increases, right? Correct? Because of air pressure difference increases, right? So when there is a big enough difference, the fellow will lift off. So you need to find out what that difference is. How?
How
As
do
in
you know
looking at
how much?
concept, look at the difference.
How do you know how much is higher?
But
How to know the difference?
Okay. Wait, is this still recording? Oh, it's recording. Shit. Okay. Okay, let's go through part B, guys. Okay, and hopefully after part B, it will become a bit clearer. Alright? Ready? Okay, don't straight away erase your answers or correction your answers, okay? They might be correct, it's just phrased a bit differently. Alright, nonetheless, I think it might be useful for you guys to copy down the answer anyway. Okay, so firstly, what I'm going to say is, they want us to explain how lift force is produced and how this force can cause an aircraft to take off. So we will say that due to the difference in air velocity above and below the wings, okay, due to a difference in air velocity above and below the wings, there will be a build-up of air pressure that is greater below the wings. In other words, because both sides are moving at different speeds, there is a build-up of air pressure underneath. Both sides also got air pressure, sorry, but the bottom side has more air pressure because they're going slower. The air gets, it's like a choke point. Okay? Okay, once I have this, okay, then I will say, since pressure equals to is force per unit area, okay, since pressure is force per unit area, there will be a greater upward force on the wings than downward. Okay, don't get me wrong, guys. The air pressure on top of the wings also generate a downward force, but the air pressure underneath is just bigger, so the force is bigger. Okay, you write like that, you get 2 marks. Your last mark will come from saying here, how this force can cause an aircraft to take off. So we will say that when the total upward force exceeds, when the total upward force is greater than the downward force, and what's another downward force I must overcome? Anyone? Your weight. Okay, when the total upward force by the air below the wings is greater than your downward force by the air above the wings and the weight, the aircraft will take off. Okay, so let me draw just a simple diagram, okay, of how the thing actually looks like. So this is your plane. Imagine this box to be your plane. Okay? You have some air pressure here, but you have a lot of air pressure below. Correct or not? Because the bottom air moving slower. So this guy generates an upward force. Okay, let me color code it. Sorry. Hold up. Let's say, okay, green is good, so I will use green. Okay, green exerts an upward force. Blue exerts a downward force. Okay, but in addition to all of these, you also have weight of the aircraft. So your green needs to overcome both blue as well as red. Then the feather can lift off. Okay? Okay. Ethan? John? Okay, good. Can Alright, so given that the area of the underside of the wings is 25 meters squared, determine the lift force produced when the aircraft is moving at 30 meters per second. Okay, so let's take a look. 30 meters per second. Focus on this part. Okay, your air pressure below 794, above 551. I'm not interested in their individual air pressures. What am I interested in? The difference in the air pressure. So let's calculate. Okay, at 30 meters per second. Okay, the air pressure difference is equivalent to, I think, 243. Is it? Okay, 243 Pascal or kilowatt? Pascal. It's not what the question is asking for. The question was your force. Ethan, what's my next step? I realize I have two Ethans now. Fuck. I was talking to them Ethan. But okay, fine. Okay, so pressure equals to force over area, right? Which means force equals to area times pressure. Math it out. Okay, so I have 35 meters squared times 243 Newton per meter squared. This is Pascal. 25 times 243, what's the answer? 6075 newtons.
You found the difference is this.
Sorry?
I found the difference.
This is the difference.
No, like if you find an individual difference.
Oh, that's fine. Both ways work. Okay? Then they say the weight of the aircraft is 25 kilonewtons. What is this 6075 guys? In terms of the arrows here. Anyone? In terms of these arrows, where green is your upward, blue is your downward, and red is your weight, what is this 6075? Okay, your 6075 is not just green, it's green minus blue. Because I minus off 243 is below pressure minus upward pressure. Right? So I have accounted for the blue color force. I have a minus weight. This is just lift. Okay? But then the next part says that the weight is 25,000. So at 30 meters per second, can I lift off? Cannot. So now, tell me how fast I need to be going. The lift force I produce needs to be at least 25,000. Try it. Zero. What?
Okay, so the area is 225.
Am I using a different plane?
We can find. Also, the pressure difference is really
Okay guys, so your green, your upward force and your downward force. Okay, you have one upward, two downwards, right? Your upward is caused by the pressure, the air pressure below the wings. Right? Then your two downward, one of them is weight, the other one is the air pressure above the wings. So to fly, you need to have a resultant force upwards. Agreed? So this green needs to overcome both blue as well as red. At 30 meters per second, I'm only able to generate 6,000 newtons worth of force. How fast do I need to go to achieve this? I need to overcome weight, then I can fly. Easier? Easier? No?
But after you find the pressure difference, how are you supposed to calculate the speed?
In the same way that I use this, I found air pressure difference, I managed to get force, right? Yes. Is it what? Divide. Divide what? Can you work answer? 70. Good. I need to be going at least 70 meters per second. Now, let me go through this now, guys. Okay? I say again, this is your plane. You have this, F up, you have this, F down, and you have weights. Why is it so small? You have weights. This 6,000 was F up minus F down, correct? Correct. I get it. Yes, okay. So your F up minus F down is 6,000 when I'm moving at 30 meters per second. I'm too slow. I need to go faster. Because the faster I go, the higher this value will become. Right? Because this is based on pressure difference. So your difference in force, okay? Difference in force is related to difference in pressure, which is related to the velocity of the plane. Okay. Is that my recording, please? Yes, okay. So, I need to generate at least 25,000 newtons to be able to lift the plane and overcome my weight. Okay, how to do that? Okay, I need to find out what this value is first. So, what will be your difference in force? Your difference in force, your benchmark is 25,000 newtons. I need to overcome this. 25,000 newtons. Okay. John, what pressure difference do I need? What's the pressure difference that I need? Yeah. What's the difference? Then 25,000 newtons is acting over 25 meters squared. What's the pressure difference that I need? 1,000. Pressure difference equals to 1,000 Pascal. We okay? Sure? Huh? How do I do that? What to do with this? Very good question. With my pressure difference, let's look back up at the table. Which velocity gives me a pressure difference of at least 1,000? Huh? 70. 3,000 versus 4.3K. Right? So when I'm traveling at 70 meters per second, can you guys calculate now? Okay, what is the lift force that I produce? What's my lift force? Hear me? If your okay, give you a little confidence percentage of set to say, if your answer starts with 3, you're on the right track. Very good. Okay, you should have produced about 33,000 newtons worth of lift. Right? And this fella is enough to overcome your weight of the aircraft. Which is what you want. Okay? Okay? Okay, okay, if you guys want to, you can calculate the 60 meters per second and find out how much lift force you will generate. You'll find that your lift over here confirm less than 25 kilonewtons. Not enough to overcome weight. So your fella cannot fly. Okay? Good, Okay, fantastic. Question 5. Yes. Turning effects of forces. You need a break. Does anyone need a break? Yeah, you guys are okay. Moment. Yes. Force times perpendicular distance.
Perpendicular to the force, right?
Agree. Perpendicular to your force and your pivot.
I never give moment. How to find force?
Principle of moments. What's your principle of moments? Can you remember? For an object in equilibrium, your clockwise and anti-clockwise movement is equal. So, once you identify your pivot, which is indicated for you very nicely, you can calculate what your clockwise and your anti-clockwise movement is really about.
But you never like write the weight of the thing. No, like yeah, trolley.
But the pivot is where the weight is bending.
Oh.
Correct. All your weight is acting on the wheel.
Oh. Oh.
That's why your wheel is there. But it's okay. Time to go through. Ready? Yes. Gonna do? Okay, so you have an airplane passenger, 2 identical luggage, each of mass 15 kg, blah blah blah. Center of gravity is in the middle of the luggage. So, luggage number 1. 15 newtons, acting 20 cm away. Correct or wrong? Wrong. Why wrong? It's 150 newtons. Indeed. 15 kg, 150 newtons. Why is it 20 cm? Because 20 is half of 40. Center of gravity is in the middle of the luggage. Center of gravity is in the middle of the luggage. So if the luggage is 40 cm long, center of gravity is 20 cm. Yeah. Your luggage 40 cm, right? 40 cm luggage. Oh my god! You're here. I thought I told you just to like. Okay, never mind. A little bit later. Didn't? Your luggage 40 cm long, correct? No? What's half of 40? So 20 cm away from either end, where your waist, I think. What the fuck? Fuck you lah! How do you? Shit! Okay.
So isn't it just 40
No, it's not. And I'll tell you why. Okay? It is because I have 150, the other fella also got 150. But this 150 is not acting the same distance away from your pivot. Because the luggage could shift a little bit, huh? Right? Yes. If you shift the luggage, your center shifts also. Okay, right? Okay. So can you tell me? What's the distance here? What's the distance from this one to the pivot?
40 cm.
But yes, it is 40 cm. Why did I do that? Because I wasn't asking you.
Oh, like that.
Carry on. How many figures am I holding up?
Carry on.
Okay. Eh shit, wait, I realized I'm not recording. Hold on.
Bro.
Oh no, I was recording, but your freaking destructive shit just knocked over my phone.
Wait, the question. How long is the base of that trolley? Need 40 cm too.
Not sure why that matters.
Yeah, so I cannot do part C, you know.
Can, but wait, let me go through this. So, if I want to counter, okay, this is your pivot.
What? In case one runs out, and then in case the
Oi.
other runs out.
Come still on top, shut up. Okay, so these two guys exert what kind of movement? CW or ACW?
Clockwise.
CW. So that means this fella needs to provide your anti-clockwise movement. Okay, so by principle of moments, okay, this fella's in equilibrium. Everybody is stationary, everybody is stable. Okay, your ACW equals to your CW. Your ACW, okay, is force times how much?
0.35.
Ooh. Nope. You need your force, your line of action of force is horizontal meter. It's 1.2. meters. Yes. Okay? Kara, what's my clockwise movement? Don't need give me the mathematical sum, just tell me how to solve. Like, what's the numbers? Like, what times what or what plus what? What's your clockwise movement? this 150 newtons, is he clockwise? Is he providing a clockwise movement on the trolley? No? Yes? Are you sure? Why? Because if you exert the force, this fella's gonna go this way. Right? Right? Same as for this one. This one also gonna go this way. Clockwise. Okay? So, with that in mind, cos was 150 times down here 20 cm. Please convert him to meters as well. It will be 0.2. Then your next luggage, your luggage number 2 is 40 cm away. So you need to convert this guy as well. Anybody else? Nobody else, Jonathan, sure.
What?
Nobody else?
No, I was shaking at home.
Okay. So, your force value that you should get here is how much? Anyone?
75.
75 newtons. Thank you. Okay? Okay. Kara, sure. Okay, you do for me part 2.
Because your honeymoon.
How's my what?
Honeymoon.
It wasn't a honeymoon. Shut the fuck up, wait. Hello? Okay, airplane passenger wheels the trolley as shown for 115 meters. Frictional force is 25. You want useful work done. Useful equals to total minus useless. What's my total work done?
Like literally holding the trolley.
Agree. It is the force that you are exerting on the trolley, ma. John, what is your total work done?
It's a
3750. Is it 3750?
25 or 50.
What? How you 3750?
25 or
25 times 150. 25 times 150, is it useful? Is it total work done?
This is 75.
This is friction. What force should you be using for the energy that you are inputting into the system? It is the 75 one, not the 25. The 25 is the wasted energy, it's the useless one. So actually my total work done, okay, by the way, your work done formula, I hope you guys know how force times distance. Okay, so force of 75 times 150 meters, your useless work is 25 times 150. And from here you get your answer. $7,500 joules. Okay, force, this is total force, your F. F times D minus useless force, which is friction, times distance as well. Okay. Yeah. Cheryl, good. Katie, good. Tara, good. Ready? Okay. If the airplane passenger lets go of the handle, it becomes upright. What will happen to luggage 1 and 2? Okay, to do this question, guys, I'm going to erase all of this shit. Erase, blah, 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 erase. Okay, and we are going to look at this very simply. If I'm going to rotate him this way, aka now he is upright. Okay, if he is upright without my force, okay, your luggage 1 is going to be like this. I'm just going to draw a half-S rectangle. Right? And then I'm going to draw another half-S rectangle over here. Right? Can you guys see very, very obviously that number 1 stays on the trolley, but number 2 will fly off? Why does number 2 fly off?
It's like a mad clockwise movement.
Correct. Because number 2's center of gravity is over here. He's acting directly in the center. So initially he's already at a very thick railing. Already at a very thick railing. So if you tilt him a little bit more, this fella's gonna fall off. Okay? But how are we going to phrase it in a moment's answer? Okay, we will say that. Okay, firstly, luggage 1 will stay on the trolley. But luggage 2 will fall off. Okay, how are we going to explain it? We will say that luggage 1 weight, luggage 1's weight is acting within the base of the trolley. Hence, it remains. Hence it remains on the trolley. Luggage 2, however, okay, the weight of luggage 2 has a line of action beyond the base of the trolley. Okay, hence producing a resultant clockwise moment. Causing it to fall. Okay, you guys can see very clearly that there is a very small but very notable perpendicular distance here. So this one generates a resultant moment. And then this fellow will topple over. Okay, but the first fellow, his center of gravity is still within the base, so it's fine. Understood it? Yes? Yes? Understand? Okay, Alright, good.
What the hell?
5.
Wait, Nick, what if we just add and say that like it will no longer be of an equilibrium and thus it won't like somewhat stay?
Number 2 is no longer in equilibrium. Why is it no longer in equilibrium? I need to see this. We are going to skip question 6, but I want to go to question 7. Okay, actually no, in the interest of time, I'm just going to go through question 7. Okay? As I'm going through, if I'm going too fast, just raise your hand and let me know. Alright? A 4 meter long uniform pole, mass of 15 kilograms. Pivoted at one end, held in position by a horizontal cable. You also have a 25 kg mass that's suspended from the end of the pole. So this fella, instantly, use your ruler and note down 250 newtons straight away. Okay, this kind of little things can help you in your exam. Okay, so you don't get confused with kilograms or newtons or whatever shit. Alright? Same thing for your uniform pole. Exactly in the center. 150 newtons. Okay, actually this one gives you the answer for part A. 15 times that. Fair enough? Okay. Alright, good. Mark out clearly the position where all of the weight of the pole appears to be acting. We have just done it. This one is your part E. The position on the pole, aka the center of gravity. Okay, so far. Now, part C, okay, determine the tension in the horizontal cable. Now, take a very good look, guys, okay? Where would I set as my pivot on this whole diagram? For there to be a moment, you need to have a pivot, right? Because you need a perpendicular distance. Where's my pivot? This one.
Yeah.
If this is your pivot, then down here will exert zero moment, which will make the question impossible to solve because I need to know what this tension is. I cannot ignore that force.
Okay, then you can just start of the cable.
Start by here. No, your tension is still acting through it, right? You still have zero perpendicular distance. Anyone else want to try? What do you all think? I need to obtain this tension value.
What's the formula of tension?
Sorry, what? Where? Huh? At your 50 degrees here. This is your pivot. What do you say?
How to find tension?
Tension is just force. Just imagine it as a force
How
going
do
this
you
way.
know what tension that is?
We need to calculate, yeah?
How?
And what to say. Okay, so guys, armed with this knowledge, can you guys give this a shot? Okay, 2 marks only. Try. Alright, use principle of moments. There is a clockwise moment and there is an anti-clockwise moment. You need to equate them together to obtain your cable tension. Everybody here learn Chico already, right? Okay. You are gonna need it. You will need Chico. No, not part A, right?
What B?
Part C, yeah. Yes, you will. You fail Chico. Okay. Starts, man.
Would you get me a present from Australia?
Do you deserve a present from Australia?
See, I made the effort to come to this class.
Me too.
No, I read your future.
Today,
I did tell you guys to just watch.
why do we need Chico?
Huh?
Why do we need Chico?
Because the rod is slanted.
Okay,
But then they gave the length of the pole.
Yeah, the pole is slanted now. Okay, for example, right, let's take a look at the 250 newtons. Okay, what do you think is the perpendicular distance to the pivot?
Oh.
Yes.
Huh?
Okay, so
What?
What? This one, Jaden. Your forces, okay, moment equals to force times perpendicular distance. This perpendicular distance is from the line of action of the force to your pivot.
What's the
So your line of action of the 150, let's say, I'll just draw an infinitely long line here. This is your perpendicular distance.
Oh.
Same thing for the 250 Newton force. So use this knowledge, guys. Okay? Use this to help you. At all?
will then tell me the one of perpendicular distance from the pivot.
Okay.
Also because
Yes.
so
this is
that's so important to use the opposite.
Huh? 2 cos 50. Yes. 2 cos.
I could find this one and just get this.
Moment, simple moments.
Wait,
Force times the potential difference. Yes.
can I find this one and just get this one by halving this one?
Yes. It's the same. Because then you need a potential distance for this one. But you need a potential distance for tension.
This should be like a pretty small basket.
No, it's not. One is too much. It's very simple. Yeah.
Yeah, it is, but then this like, you know.
It's just a little bit. Yes, but it's okay. Because the concept is very simple. You need to find the perpendicular distance from the tension to your pivot. Use the same way. Extend your line like this way. Where's your cable? Your cable is acting from the highlighted part to the end, right?
Yeah.
So extend that line all the way to the left.
Oh.
Then find your perpendicular distance. Yes. You know this one? Then you know this one, right? Like you will know that you have to extend this line, right? So what will you do for tension? You also need to extend and find the line. So this one extend upwards, right? So that you get this extend upwards, so you get this distance. If you want this will you extend it this way? Right? Extend a bigger extend a bigger upwards here. So you extend it this way. You find this distance.
Nick, I think I'm wrong, but like I got 996 Newton.
996.
Let's see if you are correct.
I got like 835.
I'm like 80% sure I'm wrong.
865.
865.
Do you say
No,
865?
I was asking. What's the figure?
Mine was 835.
Yours?
996.
It's 272.
No, but we cannot find the perpendicular distance of the pivot to the cable.
Okay. In the same way that we did for the red one.
Oh, is it the same as the 25 kg one?
No, it's not.
Then how am I going to find the
Nick, is it not? Do you not use sine?
Okay.
Do you not use sign?
So this is the first perpendicular distance, right? The second one is going to be like this.
Huh?
Then what's the third one?
Right?
You're gonna sign.
Shoot. No, it's not sine, it's cosine.
Yeah, it's adjacent.
The last one, I will extend this way.
Oh, is that cosine?
Okay, then how do you want me? Oh, okay.
Sine.
Oh, that's easy, bro. Oh, my bad.
This is your perpendicular distance.
Oh,
And this is where you use sine. Can you guys see the triangle?
Oh, that's genius.
Yeah.
Okay.
Huh?
Okay. But the answer is 272.
Wait, I got it.
Ethan, okay now?
Wait, I don't need like.
Cheryl? Don't know also. Don't know how to do at all. Really? Why?
Wait, I got it.
John?
I got it.
3, 8.
Yeah, I got 272.6995827.
Okay, good.
More this.
Okay, come. Let's do this, guys. Okay? First things first. This fella's in equilibrium. Everybody agree on that, right? He's in equilibrium, he's staying still, man. Okay, so your formula, straight away we will say POM. Okay, your ACW is equivalent to your clockwise moment. That's one.
Sorry, Nick.
Still one presence. Now, can somebody tell me? You have 3 forces listed over there. Which one or which ones give me anti-clockwise movement? Is it tension, 150 or 250? Tension. This fella is the contributor of your anti-clockwise movement. Okay? Okay, think about it. You pull the fella like this, it's going to rotate like that one. This is anti-clockwise. Okay? So, let's calculate it. Okay, I have tensional force. What's my blue color perpendicular distance, guys? It is the same as this one.
Sine 50 equals to hypotenuse over 4.
Your hypotenuse, here, which I will highlight green, is 4 meters. It's 4 meters. So what's the blue perpendicular distance?
Sine 50 times 4.
Correct. 4 sine 50. Using 3 code. Alright? John? You don't want to use 3 code?
Cannot use sine 4. Sine 90 over 4 equals to sine 60 over that one.
Sine 90 over 4. Wow, use sine rule can.
Then I get
Don't be sine 90 over 4, sine 90 over 4. You go to sine 50 over your vertical distance, right?
So it's 4 centimeters.
It's 1 over 4. Sine 90 is 1. Okay, good. So down here is 4 sine 50. Correct, huh?
Let me get sine 50 first.
It's the degrees.
Let me copy first.
Okay, finish your papers.
only this question deserves more than 2 marks.
No, it doesn't. What's your clockwise moment? 80.
It's called
Yeah. This balance is equilibrium, so yeah, anti-clockwise means more than clockwise.
What is the clockwise?
Stands again, just to piss me off.
What?
What's the force then?
What is the force?
Clockwise.
Yeah, so you tell me now, which forces are involved in your clockwise movement?
What is it?
15 kg is not a force.
150.
Okay, so your clockwise are these two guys here. These are your clockwise forces, your clockwise movements. Because if I let go of the cable, these two things will cause the fellow to go this way. Okay, so force times distance, it will be 150. What's my perpendicular distance for the 150 Newton force? The red color one.
Cosine 50.
1.9.
No, 4 cosine 50.
4,
2 cosine 50. 2 cosine 50.
2 cosine 50, yeah? Because remember, 150 is your weight, it acts in the center. So this is only 2 cosine 50. Okay, not 4. 2 cos 50. But then I also have my 250 Newton weight. I still have my ball here, who is acting 4 cosine 50. Take a good look first. Make sure you get it. Okay, it's just force times distance, force times distance, force times distance. And then moments must balance out. Are we okay? Kara? Okay? Sure? Naomi? Fine? Good? Ethan? Okay, sorry, you haven't done moments, right? Yeah, that's alright. That's alright. Cheryl? Understand the link? Dylan? What's your force? What's your tension that you got?
Based on that.
Based on your answer lah, you got do or not?
I didn't know to do it.
Now you still don't know how to do?
Now I know.
Then do it.
Yeah.
Ethan, shut up.
Wow, it's really simple. 1.5.
Yeah.
What the hell? Oh, right, I forgot you have a fucking calculator. 272.71 or 270 actually. John? Okay? Can Cool. Okay. One and second.
Wow. What
All
shot?
that shit.
Oh yeah, sure.
You stop it?
Not even.
I was playing like this.